Okay, we have a florist here who wants to estimate the portion of people who would purchase his flowers. And let's assume that it's 5% is the actual one, but he or she may not know that, so they're going to conduct a sample randomly. We hope sample 300 people and try to find out if each of these people would want to purchase the flowers. And then what's the chance that this sample proportion is going to differ from that 5% by less than 3%? In other words, if it would be 6%, that would be less than 3%. If it would be 7%, that would be less than 3%. We could be as far down as 2%. That would be the lowest. That would be 3% below our 5%. Or we could be as high as 8%. That would be the highest. That would be within 3% of the 5%. So I think it helps a lot to draw a picture on ones like these. And right smack dab in the center of our distribution, we're going to have a portion of p equals 0.05. And I really should label that, but I think things will get pretty crowded here. So I'm just going to leave that as 0.05. This here would be 0.08, and over here would be 0.02. So notice that I've stayed within 3% of this average, the average proportion or the population proportion. And the whole point of the problem is to figure out what portion of this normal distribution, of the z distribution, is shaded right now. Once you recognize that, there's a few ways to go about it. There's two main ways, just depending on which tables you're more comfortable with. So let me talk basic strategies. The first strategy to getting this shaded area would be to get the distance between the center and this 0.08, so just the right side here, and then double it. So there's one of the charts that goes from 0 to positive z. You could be using that chart and then just doubling the area you get. A second method would be using the charts that give you everything to the left of a given z-score. If we were going to use that, we'd get the z-score for this point right here, and then get everything to the left of that using the table. So that would give us the entire region, including everything we want, but also this little part we don't want. Then we'd also have to get the z-score for this point and look that up on the table. Whatever portion is to the left of this z-score, we'd subtract that out, and then that would give us the area. So we'd be taking everything to the left of this point, which includes the part we don't want, and then subtracting out that part we don't want. So either of those methods we use, we're going to have the same starting point, which is we need to get the standard deviation here. I'm going to get that by p times 1 minus p over n. So in this case, we have our 0.05 times 0.95 over our sample size of 300. And let me grab a calculator here. Okay, and that equals about 0.0126. And here's where we have to decide which, well, I guess we could go ahead. Either way, we're going to get the 0.08 minus 0.05. Now we're over the standard deviation, so this is point. Okay, and I'm going to calculate this again real quickly. Okay, and this gives us a z-score of about 2.38. So I could, again, use that first table. I could use the table that gives you between 0 and positive z, not negative infinity, but between 0 and positive z. Look up this number, get that portion. That would be the portion right here, and then we would square it to get the total shaded portion. I'm going to go ahead and go through the other way, which means we're going to now try to subtract out that little tail that we don't want. We'd have a very similar calculation here. In fact, you'll notice here that the top is going to be positive 0.03, the bottom is going to be negative 0.03. So we're going to end up getting just the negative version of that z-score. So if you recognize that, that goes a little quicker. But either way, we need to look up this 2.38 in z-score table. So let me grab that. Okay, so 2.38, notice that the z-scores are on the edge. The 2.3 is right there, and then the 8 would send us right here. That gives 0.9913. So maybe I write 13, and what that's saying is 99.13% of the distribution is below this score of 0.08. So it's actually, this center area is a lot more than it would look like in my picture. But that's still, that 99.13 includes this portion right here. And so I would need to look up negative 2.38. So that would be up on the negative infinity to negative z chart, and that would be 0.0087. So I'm going to put that right there. So we're going to say just a little under 1% of the distribution is in that left tail there. Now, since these were the same z-score, just the opposite sign, I could have also taken 1 minus this number to get that as a shortcut. But it's fine to look it up also. So 99.13% of the distribution is below this 0.08. 0.87% is below this point. So if I just subtract the two here, 0.9913 minus 0.0087, that would give me 98.26% of the distribution. And if I go back to Hawks and submit, I will get that correct. Just to clarify again, when I had that 2.38 right there, when I talked about going from 0 to 2.38 and then doubling it, if I would pull up my tables here, and instead of using the two that I used, if I would, it's kind of blocking me here. If I would go this area 0 to z instead, and I would look for 2.38, 2.38. Notice I'd get 0.4913. So 0.4913 would be this area right here. I would then double that to account for this same area on the opposite side, and that times 2 would also give me 0.9826. So two different ways to approach it.